It's about time to learn about time. After this series, you are expected to be able to understand how time works and to read, convert, and compute time. Okay, so let's do conversion of common time units. After this video, you are expected to be able to understand leap years and convert time into different units. So I have this chart here. Each day is composed of 24 hours. The 24 hours are further divided into AM and PM, which is before and after noon. Each hour is also divided into 60 minutes, and each minute is divided into 60 seconds. 1 week is 7 days, and 1 month, that's a little bit more complicated. It could be 28, 29, 30, or 31 days. Just remember that months of 31 alternate with shorter months, except for July, August, and December, January, which are all 31. And February has 28 days and 29 during leap years. But what are leap years? So leap years are needed because the Earth takes a little more than 365 days to orbit the Sun. There's about one extra day for 4 years of 365. So there are leap years where there's an extra day, which is February 29. Leap years add one day, which is the 29th of February. If the year is divisible by 4, check the last two digits. For that, it's a leap year. Else if it's divisible by 100, it's a normal year. But if it's divisible by 400, it's a leap year. However, that is a bit slow and complicated for me. To see if a year is a leap year, you need to check the last two digits. If they're divisible by 4, then it is a leap year. But if the last two digits are 0, you remove them and check the next two digits instead. If they are divisible by 4, then it's a leap year. But if all the last 4 digits are 0, then it is a leap year. So let's try a few examples. First, 2022. So the last two digits are 22, not divisible by 4. But let's make it 2024. Now 24 is divisible by 4, so it is a leap year. So what about the year 1900? So the last two digits are 0, so let's check the next two digits. 19. So 19 is not divisible by 4, so it's not a leap year, even if the last two digits of the year are 0. So now, for the final example, 2000. So again, the last two digits are 0, so let's drop them and let's focus on the 20. The 20 is divisible by 4, which means it's a leap year. So if you see a year like 10,000 or any multiples of that, those are also leap years. So now let's use ratio and proportion, or as some might call dimensional analysis, to convert time units. So first, 5 hours equals how many minutes? So to convert that, we use the version factor. 1 hour is equal to 60 minutes. So we take 5 hours, then divide the 1 hour, then multiply by 60 minutes. So the hours should cancel out. And multiply 5 by 60, we get 300. So 300 minutes. Now let's do a more complicated example. 10,800 seconds is how many hours? So first let's convert seconds to minutes, then minutes to hours. So 10,800 seconds divided by 60 seconds multiplied by 1 minute. That should cancel out the seconds and one of the zeros. Then we divide by 60 minutes and multiply by 1 hour. Is our next conversion factor. So that should cancel out the other zero and the minute unit from the last conversion factor to change it to hour. So we get 3 hours. And yes, conversion like this uses a lot of zeros, so maybe better if you are able to cancel out the zeros and common factors if you spot any. Here's a recap of all the conversion factors. Then finally, for a bonus take, every full year and February 29th, the day of the week increases. This is because 364, which is one less than the number of days in a year, is divisible by 7, which means every year the day of the week increases. Let's say January 1 is a Monday on 1 year. The next year it's Tuesday. And every time February 29 is passed, one extra day is added to. So that's it.